So this is plus 4, that's minus 2, this is 0. 3 oxygens, so minus 6. There's no charge here, so 0. Yeah. There's only 1 sulfur here, so it must be plus 6. So this is plus 6 and minus 2. Now, this oxygen doesn't change across here, so we're just going to ignore that one and look at what's left. Sulfur does that, and this oxygen does that. Which one of these had its charge reduced? Oxygen. It went from 0 down to negative 2. And sulfur had its charge go up from 4 up to plus 6. And then everything else I wrote before applies. It's reduced, it underwent reduction. What else did I say? Reduced, reduction. I can say gained electrons, lost electrons. And this is the oxidizer, it's the oxidizing agent. It caused oxidation to occur over here. You okay? I2, 2K2SO. Split this into two things. That's a polyatomic ion, SO minus 2, which means copper is 2 plus here. What is the oxygen here? Well, it's negative 2, negative 2, negative 2, negative 2. That's 4 of those, so that's a negative 8. The charge here is minus 2. All right, so what do I need here to make this true? There's only 1 sulfur here, so it's plus 6 for sulfur. So copper is 2 plus, sulfur is 6 plus, and oxygen is 2 minus. Ki, you know the charges on these. If I split them out, what's the charge on potassium? Plus 1, and iodine. Iodide is negative 1. So that's 1 plus and 1 minus. Copper over here, if I split these out, I have copper. And what's the charge on iodine? Negative 1, so this has to be plus 1. So this is 1 plus and 1 minus. What about here? These are easy if you recognize them. It's elemental. You see it? H2O2N2 F2 Cl2 Br2 I2. So don't miss those. Those are always 2. In any metal, like Fe, if it's got an S there, that's also elemental. That's by itself. This is just hydrogen, just oxygen, just nitrogen, just fluorine, chlorine, fluorine, bromine. In any metal that you see by itself, it also means, I think at room temperature it's bromine. It's liquid, so you might see L on it. But this is elemental, I2 is elemental. This thing I downloaded is not giving me the state of all of these. I could guess, but I'm not going to. All right, so there's that. K2SO4. We split this off into 2 Ks in SO4. SO4 is 2 minus. K is 1 plus. So this is 1 plus. I already did the SO4 over here, and it's going to be the same. So minus 2 and 6 plus. So I just copied those up from over here because SO4 is, we already did. You with me? It's just going to come out the same. So what do we got? I know iodine changes here. What else changes? I bet it's the copper. It's the copper. Okay. Which one of these had its charge reduced? Going from one side to the other. Copper was at +2 and it ended up at +1, so it reduced. Which means this oxidized. This gained an electron, this one lost an electron. And of course, this is the oxidizer, it's the oxidizing agent. It caused oxidation here. This is the reducing agent because it caused reduction here. Because of that electron swap. Electron transfer. You guys okay? That sulfur is a solid. This chlorine would be a gas. This H2S, hard to tell from what I'm looking at. It could be aqueous, it might not be. Okay, starting here. The rule with hydrogen is when it's on a non-metal, it's +1. And when it's with a metal, it's -1. So here, that's 1 plus. What's the charge on sulfur? If you were looking at a periodic table. So that one's 2 minus. What about this? 0. And how about this? Okay, here, that's -1, that's +1. So 1 plus and 1 minus. Do you see where I'm getting these charges from? Am I going too fast? Hydrogen doesn't change, it's +1 on both sides. Sulfur changes. Chlorine changes. Which one of them had their charge reduced? Chlorine went from 0 down to -1. So it was reduced. Sulfur went from -2 up to 0. You with me? Why did what? This went from 0 down to -1, so it reduced. This one went from -2 up to 0. because they're there. Guys. Liquid. If this were the chapter on ionic compounds, and I said, okay, what's the charge on oxygen? Oxygen is -2, so lead has to be, so that's 2 plus and 2 minus. Hydrogen connected to a nonmetal, it's going to be +1. And what's the charge on nitrogen? 3 minus -3. Just like in the ionic compounds chapter. When I point at something, turn around and look at you longingly. Huh? 0. That's elemental. It's only nitrogen. Looking at you longingly. So what is this? It's just lead. So it's elemental. H2O, so non-metal, so this is going to be +1, 1 plus, 2 minus. Oxygen doesn't change. It's 2 minus, 2 minus. Hydrogen doesn't change. But we have lead changing. +2 to 0. And what else? Nitrogen. All right. Which one of these had its charge reduced? Lead was a 2 plus and it ended up at 0. So that one went down. So that was reduced. It gained electrons. So that means this one was oxidized. Lost electrons. Get the hang of this. This is the reductant. It's the reducer. It's the reducing agent. But it itself was oxidized. It underwent oxidation. I just have a few more of these to do. That's 3 carbons. Solid. Okay. 0, it's elemental. There's a 3 there, then an S there that says solid, but there's only one element there, so it's elemental. Do you see any other elemental? Fe. That's elemental. It's just iron. That one's 0. Oxygen, so -2, -2, -2. It's a total of -6. There's no charge here, so I'm going to say equals 0. So for this to work, this has to be +6. There's 2 irons there. So if I'm going to split that +6 among 2 irons, I'm going to have to make them both 3 plus. So this one is 3 plus, and this is 2 minus for oxygen. Oxygen 2 minus, 2 minus, a total of -4. There's no charge here, so I'm going to say 0. So this has to be +4. There's only 1 carbon, so it has to be 4 plus. So 4 plus, 1 minus. You follow me on this? I know I'll go quick, but I expect you to interrupt me if I'm losing you. And what do we have? Carbon changes. Iron changes. Oxygen does not change. It's -2 and -2. Which one had their charge reduced? Oh, yes. I thought it was carbon. Yeah. So from +3 down to 0. So it gained electrons to get there. How many electrons did it gain? 3. You get 1 charge per electron, so if it goes from +3 down to 0, that means it gained 3 electrons. And then this is oxidized, lost electrons. Which one is the reductant? Huh? Carbon is the reductant. Carbon is the reducer, the reducing agent, the reductant, because it's causing reduction to occur here. It lost electrons, so it allowed something else to become reduced. You guys okay? How many more do you want to do?
Let's do one more.
I was going to say 4, because that's how many I have. P2O3 plus 2Al. Solid. Okay, first, tell me the elemental ones. That one's elemental and that one's elemental. Probably a pretty good guess, those are the ones changing. -2, -2, -2, total of -6. No charge, so I'm going to say 0. That means this has to be +6. We've got 2 FEs. We're going to split the +6 among them, so these are 3 plus. So this is 3 plus, and this is 2 minus. That one's 0, that one's 0. -2, -2, -2, -6. No charge, so I'll put 0. Got to be +6. And there's 2 aluminums, but you probably already know this would be 3 plus. So what's changing? Aluminum, iron. Which one had its charge reduced? Iron went from +3 down to 0. Gained electrons, and aluminum went from 0 up to +3. So this was I do have 3 more, but I'll get them on D2L so you can have practice.
Are we going to do any more balancing redox reactions?
I want to go look and see if that's on the ACS file. I mean, there's simple balancing, and then there's balancing under acid conditions and balancing under base conditions. And the book did have base conditions. I just didn't see it the other day. I should have known when that OH was sitting there, but I want to check that before we go into it, because I'd rather go on to other things. So I'll check that either this week or over break, and I'll come back to it and decide if I will. Are there any questions? Is there anything else in this chapter? Next. If we don't do the balancing, what's next is thermochemistry. So I expect to do either all or most thermochemistry before test 2. Yeah, that's good. No, I'll probably do electronic structure too. So I'll probably do all of thermochemistry and part of electronic structure, which I'll be moving on to Wednesday. So don't skip just because we're not having a lab. We've got lecture to go through as well.